cooling power of sea ice is decreasing faster than its surface area. There is less and less sea ice every year. This reduces the ability of the Earth's surface to reflect sunlight, which results in accelerating climate change. In a recent study, scientists found that as sea ice has disappeared and its ability to reflect light has decreased, the Arctic has lost about a quarter of its cooling power since 1980. The Arctic and Antarctic are changing rapidly. Sea ice is getting thinner and there is less of it every year. This is due to the increase in temperature around the world. However, the increase in temperature in the polar regions is much faster than the global average. Sea ice performs functions similar to air conditioning in our homes. It has the power to cool the entire planet. However, according to scientists from the University of Michigan, its power is no longer what it used to be. Satellite measurements of cloud cover and solar radiation reflected by sea ice from 1980 to 2023 have shown that the decline in sea ice cooling power is about twice as large as the decline in the mean annual sea ice area in both the Arctic and Antarctic. And the decline in cooling power means a greater impact of global warming. The results in a description of the study were published in the journal Geophysical Research Letters. The Arctic has experienced the largest declines in sea ice cooling power since 1980. Until recently, it seemed that the South Pole was more resistant to the changing climate. Antarctic sea ice cover remained relatively stable, and its cooling power was even increasing. But that all changed in 2016, when there was a rapid loss of massive amounts of ice. An area larger than Texas melted on one of the continent's largest ice shelves, leading to significant sea ice loss and a reduction in its cooling capacity. 7 consecutive years are the weakest global cooling effect of sea ice since the early 1980s. As ice is lost, the ability of Earth's surface to reflect sunlight is diminishing. This means that more radiation is being absorbed than before, accelerating climate change. In addition to the disappearing ice cover, the remaining ice is less able to reflect sunlight. Warming and increased rainfall are creating thinner, wetter ice. More puddles or ponds appear on the ice surface, which reflect less sunlight. This effect is most visible in the Arctic, where sea ice has become less reflective during the sunniest parts of the year. The cooling effect of Arctic and Antarctic sea ice was about 20% and 12% weaker, respectively, between 2016 and 2023 than between 1980 and 1988. The ability to reflect sunlight has decreased by 13% and 15%. The loss of sea ice affects not only global temperatures but also ecosystems. Sea ice provides habitat for a variety of organisms, from the tiny algae that form the base of the marine food chain to larger species such as seals and polar bears. The reduction in sea ice affects the habitats of these species, leading to changes in their distribution and abundance, and ultimately alters the ecological balance. For example, the loss of ice platforms affects the ability of polar bears to hunt seals, which can lead to nutritional stress and bear population declines. Changes in sea ice can also affect the timing of algal blooms, affecting the entire food chain. This cascading effect highlights the interdependence of climate systems and biodiversity.